Algebra 2 Honors, 8.3. And then we're doing this all in one day, and I just forgot to put off day one. But anyways, identifying a geometric sequence. Geometric sequences are when you multiply by the same value to get from term to term to term. So in example 1, when they say, is it geometric, you want to look, we call the common ratio R. And how you do it is you take the second term divided by the first term. So we're still going to use this is a sub 1, this is a sub 2, this is a sub 3, this is a sub 4, this is a sub 5, etc., etc. So the subscript gives you the term number. But, and so you take negative 18 divided by negative 3, and then you, to tell if this whole thing is geometric, you want to take then the third term divided by the second, and then the fourth term, so you're taking each term divided by the term in front of it, and just check to see if they have the common ratio. And all of these come out to 6. And so therefore, the sequence is geometric. So in part B, I'm going to take 3/4 divided by 1/2. And then I'm going to see if that equals 5/6 divided by 3/4. And this first one is going to come out to 3/2. And that doesn't equal the next one. When you take 5/6 divided by 3/4, it comes out to 10/9. And so right there, they're not equal. The ratios are not constant, so it is not geometric. All right, so then we come to writing a rule for the general term, the nth term of a geometric sequence, and this is the formula, because as you go from term to term to term, you end up multiplying by r to one higher power. For example, so say a sub 1 is 3, and let's just say r is 2. Well, you're going to get the second term by taking 3 times 2. Then you're going to get the third term by taking the previous times 2 again, which makes it 2 squared. The fourth one would be 3 times 2 cubed. And you get down to the nth term. It's going to be 3 times 2. Well, the number of times you've multiplied by r is 1 less than the term number. For the second term, it was to the first. For the third term, it was squared. For the fourth term, it was cubed. And so this produces this kind of pattern for the general term. So write a rule for the nth term and then find a sub 10 and give exact values. You have to show use of formulas and you have to show work. And so for the common ratio, we can take that second term divided by the first term, and that is 1/3. And since you can see if I take 2 times 1/3, I'm going to get 2/3. 2/3 times 1/3 is 2/9. It is geometric, because when you get to the test, you're going to have both arithmetic and geometric, so you need to make sure you know which one you're working with, so you use the correct formulas. So that means that my a sub 1 is 6, and my r is 1/3. And so my general formula, a sub n, is a sub 1 r to the n minus 1. That general term is going to be 6, and then the 1/3 to the n minus 1. Do not make the mistake of thinking that this is equal to 2 to the n minus 1. Don't make that mistake. You can't, that's the wrong order of operations. You have to take the 1/3 to the power first, before multiplying by 6. So that is as simplified as that gets, and that's part of your answer. What is that general term? Then you need to find the 10th term. So it's just a matter of plugging in 10 for n. And so sometimes this requires some pencil and paper work to kind of break it up individually. Sometimes they get too big for a calculator to switch to an exact value. We don't want a decimal approximation. And so what you get is 1 to the 9th, which is just 1, over 3 to the 9th. And you might, depending on your calculator, have to work that out independently. And what happens is that simplifies to 2 over 6,561. So check it out and make sure that you can get that to simplify to that value. Now, in part B, I can see that I'm multiplying by 2 from term to term to term. So again, how we show it is we take the second term divided by the first one, and it's 2, and then you just check that you are constantly multiplying by 2 to get to each term, and you are. And so r is 2, and the first term is 10. So the general rule is a sub 1 r to the n minus 1. So that general term is going to be 10, 2 to the n minus 1. Again, do not make the mistake of thinking that's 20 to the n minus 1. It is not. That's the wrong order of operations. You must take 2 to the power before multiplying by 10. So that's as simplified as it's going to get for the general term. That's part of your answer. And then plug in to get the 10th term. So you're going to get 10 times 2 to the 9th, and you need to do the 2 to the 9th first. And when you multiply that out, you're going to get 5,120. So example 3. Given a term that's not the first term and the common ratio, write the rule for the nth term, and you must show use of formulas. Number crunching to try to get to the end answer is not going to give you any points at all. You have to show use of the formulas. And so here you know a term, so write down the general term and plug in what you know. And this is the 5th term, so that is when n is 5. So that 5th term is 32. And we don't know a sub 1, but we know the common ratio is 2/3. And that's going to be to the 5 minus 1, because 32 is the 5th term, so n is 5. So just work it out algebraically. You get 2/3 to the 4th. Exact values, no approximations. And so that is going to be 16 over 81 times a sub 1. So to solve that, multiply by the reciprocal on both sides. This is one way to do that. And you're going to get a sub 1. 16 goes into 32 2 times. 2 times 81 is 162. So the rule, a sub n is a sub 1 r to the n minus 1, that general rule. We now know a sub 1 is 162, and we have 2/3 to the n minus 1. And you've shown use of formulas to get there, all the algebra. And if I were to find a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and plug in, a sub 1 is 162. If I multiply that by 2/3, I get 108. A sub 3 is 72. Then you have 48, then 32, et cetera, et cetera. We have these points plotted here. And on the homework, I'm not going to make you plot them. So in the directions, there will be, you don't have to plot the points where they're asking you to. But if we were to fit a curve to it, it is exponential decay. You have an r value that's between 0 and 1, so as you continually multiply by that, you are decaying. It's going down as you keep multiplying. So anyways, that 1 looks kind of funny. I'm just going to go back and try to change it. that looks a little better. All right, so anyways, writing a rule given two terms. In this one, you must show a system of equations. Number crunching will result in no credit. And so what we do here is we take a sub 3 equaling 20 and plug into that a sub n is a sub 1 r to the n minus 1. Only this is where n is 3. So that third term is 20. I don't know a sub 1. And I don't know r, but since it's the third term, you get to the 3 minus 1, this will be squared. And then we do this for the sixth term, negative 160. That sixth term is when n is 6. And so it's the first term, and it's to the n minus 1, so this will be to the fifth. So that's my system. You must show a system for solving, and then show all the work for that system. So what we're going to do is take this first one and solve for a sub 1 by dividing by r squared. So I get a sub 1 is 20 over r squared. And then I'm going to substitute that into the second equation. So that's substituting for a sub 1, and then that's times r to the fifth. And that r to the fifth can be thought of as over 1. And then these r squareds take out 2 of those, so that ends up being r cubed. So we have this negative 160 is 20 r cubed, and so r cubed is going to be a negative 8. And if you take the cubed root of that, r is a negative 2. So we need to write a rule for the nth term. So we have r, but we're going to need a sub 1. So I'm going to come back and use this formula up here. A sub 1 is 20 over r squared, which is 20 over a negative 2 squared, which is 20 divided by 4, which is 5. So I have my a sub 1 and my r. So now I'm going to write that general term formula down. And a sub n is going to be my first term, r to the n minus 1. And that negative 2 has to be in parentheses with the n minus 1 on the outside for that to work. And that's it. So let's try that again, because something else happens in part B. So we have a sub 2 is 12. Again, you must have the system of equations. So you get 12, that's the value of your second term, when you take a sub 1 times r to the, 2 minus 1 is just to the first. Then write this out for the fourth term. The value of the fourth term is 3. A sub 1, it would be r to the third, because it's always to the n minus 1, and n in this case is 4. So no matter what, I want to see the system, and I want to see them solved the way that I'm solving them. So take this first one and divide by r, so that you have it solved for a sub 1. And then substitute that into the second one for a sub 1. And we get 3 is 12 over r times that r cubed. And we can think of that as over 1. And now this r can take out one of those, leaving r squared. So I have 3 equals 12r squared. Be careful. I see people get 4 here instead of 3 over 12. Be careful, be careful, be careful. It's a 1/4 is r squared. And this is why you get 2 answers. Because when you take the square root, an even root of both sides of an equation, you need plus or minus. So you have, if r is positive 1/4 as one answer, and then you separate that for if r is a negative 1/4, you have a different answer. Now to find a sub 1, use 12 over r is a sub 1. So 12 over 1/4 is a sub 1, and you get 48. Oh, I wrote 1/4. I bet you were wondering. I was so focused on the plus or minus that I didn't actually take the square root. So it's 1/2. I'm sure you were wondering what was going on there. The square root of 1/4 is 1/2. There we go. And so we get 24 is a sub 1. And so plugging into a sub n is a sub 1 r to the n minus 1. A sub n is 24 1/2 to the n minus 1. So that's if r is positive 1/2. If r is a negative 1/2, I get 12 divided by r is a sub 1. So 12 divided by a negative 1/2 is going to be a negative 24. And so plugging into a sub n, a sub 1 r to the n minus 1, the general term for this is a negative 24, and this is when r is a negative 1/2 to the n minus 1. So you need two answers. You need both of them. All right, and then we have series for that geometric series, just like we have arithmetic series, and this is when you add up a finite number of terms in a series. And so we have this way of figuring out the formula that's kind of cool that I'm going to try to go through just kind of briefly. So this is supposed to be sub 1. I'm not sure. It looks a little funny, but it is what it is. It's just your first term's a sub 1, your second term's a sub 1 times r, your next is a sub 1 times r squared, and then you are adding these up to get the series, the sum of a finite number of terms. Well, how we figure out the formula is we multiply, I have here by negative r, but we multiply by r. And when I take 8 on both sides, and when I take a sub 1 times r, I'm going to write it underneath here. When I take the next one times r, it's r squared, and then we get r to the 4th. And then what happens is we get an a sub 1 r to the n minus 1, but then we have a sub 1 times r. As you multiply each of those on the right-hand side, you get this list that I have. But then what we do is we subtract all of these. And so if I subtract all of these, I'm changing all these signs and just adding. And so on the left, I have S sub n minus r times S sub n. And on the right, because these are all lining up and being opposite, they all cancel. We call that a telescoping sum, when a bunch of terms cancel and it simplifies to just a few terms. And then I pull out S sub n, and I have 1 minus r here. I pull out a sub 1, and I have 1. Oops, I have something missing. Oh yeah, this is r to the nth up here. I was like, there's something wrong here. A sub 1 r to the nth. And then I'm finding the sum of n terms. And so you have this a sub 1, 1 minus r to the nth, all over 1 minus r. And that is this formula, just written a little differently. I kind of like to put the a sub 1 in the numerator. And that is the sum of finite number of terms of a geometric series. So one of the ways you'll be shown a series is this summation formula again. But on this, when I'm looking at this, you have to figure out, is it arithmetic or geometric? So you should write out a few terms and just kind of look at what happens. So if I let k be 1, my first term is 1/2 5 to the first. If I let k be 2, and remember sigma, that symbol is sigma and it means to add up, I'm going to have 1/2 5, let k be 2, 5 squared, and we're going to keep on going. And if you notice from term to term, you're going to be multiplying by 5. So this is geometric. And also because this here looks like an exponential function equation, we have that 5 to the k. I expect it to come out geometric. But it's going to be important because you're going to need to choose this formula and not the arithmetic series formula for adding up, which looks different. Now, for this formula, you just need A sub 1 and the common ratio and the number of terms you are adding. You don't actually have to know the value of the last term, like we did in the arithmetic one. And so since k is starting at 1 and ending at 6, n is 6. There are 6 terms. So I'm just going to plug all these things that I know, and I'm going to use this form. And this is adding up 6 terms. If you write out the 6 terms and add them up and come up with an answer, that way you will not receive credit. You must show use of formulas. Let's show use of formulas. So n is 6, and the first term here, well, when k is 1, the first term is 5/2. And then 1 minus, the common ratio is 5. That's what you're multiplying by. And notice it's to the nth, so it's to the 6th, all over 1 minus 5. And then as you're simplifying it, I kind of think about those two terms. I have 5/2 divided by -4, which is 5/2 times a -1/4 is a -5/8. And then that's going to be times 1 minus 5 to the 6th. And then you show details like that, and then at some point you can pick up a calculator to help you evaluate, and it's 9,765. And that is the sum of the first 6 terms, but you must show use of the formula. So that's one way, using sigma notation, to have you get a sum of a specific number of terms in a geometric series. But they might give it to you this way as they do in Part B. Find the sum of the first 9 terms. That means n is going to be 9. I want the sum of the terms. That means we're going to be using this series formula for the sum of a finite number of terms. And what else I'm needing is my first term. Well, I know my first term is -14, but I need the value of r. And to get r, we take that second term divided by the first. And so that is going to end up being 3. And then I just want to check, is this geometric? Because on the test, you're going to have both arithmetic and geometric. So am I constantly multiplying by 3 to get from term to term to term? Well, if you check it out, those values times 3 will get you the next term. So it is geometric, and my r value is 3. So I can go to S sub n, and then I like it a sub 1, 1 minus r to the nth in the numerator with 1 minus r here. And I'm wanting the sum of the first 9 terms. And make sure that you do 3 to the 9th before you subtract from 1. I've seen some students take 1 minus 3 and take a -2 to the 9th. And that doesn't work. You have to do the power before you do the subtraction. And then this is all over 1 minus 3. And so if I think about simplifying these two, I have a -14 divided by a -2 is 7, and times 1 minus this 3 to the 9th. And if the r value is negative, make sure that you have parentheses around it and raise the negative to the power before you subtract. And so if you work that out, the sum of the first 9 terms are -137,774. That's it.